Alright, you guys. In this video, I'm going to talk about exponential functions. This idea of function is actually kind of new, so please bear with me. But it's really easy, and this section is actually going to be really short, so don't fret too much. The exponential function is the idea of switching the base and the power of normal functions that we usually know. For example, previously we used to see y equals x squared, where your variable x is the base, right? Or, for example, y equals x to the third minus 1. But for exponential functions, we're going to flip that. Instead of the number being the power and the x being the base, we're going to see something that looks like a little like this. 2 to the x power. And now what this means is that you have the base 2 risen to, you have the base 2 multiplied by itself to a power of x. What I mean by that is that you have to multiply it x times. Now, x could be 5, and in that case you have 2 times 2 times 2 times 2 times 2 times 2. Or x could be 50, which is actually a lot harder to multiply, so you can obviously use a calculator. But the idea of an exponential function here is that the function grows really quickly. So at first it goes 2, 4, 8, and before you know it, it's 16. So that's a big jump between 8 and 16. And from 16 it goes to 32, that's an even bigger jump, and so on and so forth. So before you know it, your function is really, really, really huge. So it grows really quickly, and it shows on the curve. So I'm gonna show you guys an example and graph the function so you can observe how it behaves. Alright? This is going to be number 1 in your note set. So let's say your f of x is 3 to the power of x. Okay? This is my function. This is the one I want to graph. Now graphing it is going to be really easy. We'll use the simplest method we know, which is using a table. So one side is going to be x, the other is going to be the function, which, as I've told you guys a few times already, when you see f of x, that really equals y, so it's the same thing. Yeah. Now, for x, let's choose a few variables. A few values, and I'm gonna choose a variety. So we're gonna choose a few positive ones and a few negative ones to observe how it behaves for all those values. Okay. Now, I'm plugging these in over here, but I'm not going to substitute the 3 because that's just a number, right? X is the value I need to plug into, which means for each of these is going to be 3 to the power of the x value it chose. Make sense? So, for example, 3 to the 0 power because it's replacing the x. And as we know, anything to the power of 0 is going to be 1. So that's the first value. How about the second one? You have 1 over here. So that's going to be 3 to the first power, which is, 3. Right? Now, 3 to the second power is going to be 3 times 3, which is 9. 3 to the third power is going to be 3 times 3 times 3, which is 27. So far so good. It's really easy. You just put the power on top and find out what the result of multiplying that base that number of times. So 3 times gives you 27, 3 2 times gives you 9, 3 1 time is just 3, and anything to the power of 0 is always 1. Now what about the negatives? What is the negative 1 power? How can you multiply 3 by itself negative 1 times? Whenever you see a power that is negative 1, you need to think denominator. What you need to do is take everything you see here and place it in the bottom. Just remove the negative. The fact that you put it in the denominator removes the negative. After that, you have 3 to the first power, which is just 3, so the answer is 1/3. Okay? Now, if I do the 2, 3 to the negative 2, again, you do the same thing. You have 1 on top. I'm going to write everything I see here on the bottom, so 3 to the second power, but without the negative. And 3 to the second power is 9, so we have 1/9. Now for the third one, I'm going to use it, solve it using a pattern that I hope you guys have spotted. Do you notice here 3 to the first and 3 to the negative 1 have kind of similar answers if you look at the base of the denominator? They're both 3. This is just in the bottom because we have the negative. So if this ever confused you, or you're not sure you did it right or not, just look at the positive equivalent, right? So look at the 3 to the first power, 3 to the second power, 3 to the third power, and look at the answers. And if the answer of that power when it's positive matches the denominator of the answer you came up with when it's negative, then you got it right. 3 to the negative 1, just put the 3, which is the answer to the first one, in the bottom. 3 to the negative 2, well, when it's positive 2, it's 9, so negative 2 is 1 over 9. When it's negative 3, well, when it's positive 3, it's 27. Can you guess what it is when it's negative 3? It's going to be 1 over 27. Just put the 27 in the denominator. Make sense? So whenever you see negative, the answer you would have had is going to be in the bottom. That's what that means. Okay? Now let's try and graph this. There you go. It's my axes. Now let's go. First one, we have x is 0, so right here, and y is 1. That point. Let me make it bigger so it's visible to you guys. Okay? When x is 2, oops, x is 1, not that 2 yet. When x is 1, y is going to be 3. So at 1, I'm going to go all the way here and say that's 3. Alright? When x is 2, y is going to be 9. So this is 1. So at 2, y is going to be all the way up here. And this is not the scale, I'm just sketching it roughly. Now, when it's 3, it's 27, and I'm not sure I can even graph that. Now let's go to the negative. When x is negative 1, which is right here, y is 1/3. So that's the 1, this is the half, this is the third, so right about here. Like that. Dot dot. When it's negative 2, which is right here, it's 1/9. So it's even closer to the axes. I'm going to graph it right here. Like that. And when it's negative 3, it's 1/27th. So it's even closer. And it's going to keep getting closer and closer and closer and closer. Now notice, no matter how small or how far you go down the x values in the negatives, the y is always going to be a positive fraction. And it's just going to keep smaller and smaller, getting smaller and smaller, approaching 0, but never quite actually getting there. So the function from the positive values is going to grow ridiculously quickly. And when it goes to the negative values, it's going to get smaller ridiculously quickly. But it approaches a specific value and sticks to it. So it's going to infinity on this side, and it's going to infinity on that side. And that's what a graph of an exponential function looks like. Okay? Now again, over here, the number you have, this is called the base. And x is your power. Now I'm only stressing these terms, even though they're kind of obvious, because in the next section we're going to talk about logarithms, and you need to know what your base is. Okay? So let's do one more example before I move on to a different topic. So how about f of x equals 2 to the negative x? Now in this one, I'm going to show you what the function would look like if it was negative. So in this case, my x is negative. Now you can technically play with this, right? So if you see another function that is written in this form, right? So that's 2 to the x, but in the denominator. Or in this form, 1/2 to the x power. These two equal that one. Let me show you why. So in this one, if we want to plug in any x value, if I plug in positive numbers, they're going to end up, the result of this function is going to end up in the denominator, right? Which is basically saying that any number you plug in here is going to be basically 2 to the x in the denominator. And that's why these two are the same. Think of what we did right here. 3 to the negative 3. The answer is supposed to be 27 when it's just 3. So since it's negative, it goes in the bottom. So 2 to the negative x power means it's going to be 2 to the x power in the denominator. Yeah? So the relation between these two is kind of obvious. Now, how does these two equal that one? Well, you see, when it's actually negative x as a power to this one, and you want to place one on top, one on the bottom, the reason we have just a 1 on top is because whenever you multiply 1 by itself, the answer is always going to be 1, no matter how many times you do it. So this right here, the fact that the power is negative, basically means that it's going to be 1 to the power of x over 2 to the power of x. Like this. It's just that whenever you multiply 1 by 1 x times, the answer is always still 1. So we don't write it because it doesn't matter. Make sense? That's how that comes in. But all these three functions are technically the same. Anyway, this is the one we're solving. And when I said all three functions are the same, I really meant it. That means that if you plug in the x values I'm about to do in this one or in that one, you're gonna get the exact same answers. Right? But this is the one we're playing with. So, x, function of x, and here's my table. Alright? So I'm choosing 0, 1, 2, 3, and then negative 1, negative 2, and negative 3. Okay? So, when it goes to 0, you have 2 to the negative x, correct? In this case, x is 0, so 2 to the negative 0. Now, 0 can never actually turn negative, so it's still 2 to the 0, and anything to the power of 0 is 1. So the answer for the first one is going to be 1. Yeah? Now, this one, where x is 1, you end up with 2 to the negative 1. So, 2 to the first power is just 2. Since it's negative, you put that 2 in the bottom. Okay? Right here. That makes it 2 to the negative 2 power. Again, 2 to the second power is 4. Since it's negative, it goes in the denominator. Negative 1. Oh, sorry, negative 3. I didn't do that one. Let's do negative 3 real quick. So 2 to the negative 3 power is going to be 1 over 8. Now, negative 1. Since it's actually 2 to the negative 1, it's actually going to turn positive. And the answer for this one is just 2. When it's negative 2, that means it's 2 to the positive 2. And that equals 4. And last but not least, when it's negative 3, the power turns into positive 3 because it's 2 negatives, and the answer is 8. Okay? Now, let's graph this one. And the reason I call this function the negative 1 is because you saw what the positive slope, the positive curve of the exponential function looks like. Now we're going to see what the opposite looks like when we started off with a negative. That means your positive turns negative and your negative turns positive, so the function is going to look mirrored. So when x is 0, y is 1, this point hasn't changed. When x is 1, y is 1/2. So it's going to be right here. When x is 2, y is 1/4. So right about here. X is 3, y is 1/8. So right about here. And as you can see, it's getting smaller on the right side this time. And on the left, when x is negative 1, y was 2. So I'll put it here. when x was -2, y was 4, and when x was -3, y was 8, and it's just going to keep getting bigger. So the function is doing this. It's getting bigger on the left side and smaller on the right side, which is kind of the opposite of what we saw above. See that? Yeah. So this is basically the idea of the exponential function. As you can see, it's not that complicated. It's just a function that grows ridiculously big, really fast. And before we move on, you guys, I wanted to show you the idea of the number e. E is a universal constant, kind of like pi. So it has a value. It's a number. It doesn't change. It's always a number. So whenever you see the letter E, don't freak out. It's not a variable. It's a number. It's just that this number, since it kind of looks nasty, people usually don't write it down. It's like 2.718281828, and I think it just keeps repeating after that. Kind of like pi, 3.1415, and so on. So since it's that nasty, they write the letter E instead. So if you see this, that's a number. It usually equals 2.718281828, and so on. Okay? Now, I'm going to show you guys a few examples where we solve e to a power. Okay? Just to get familiar with the idea of e, because we're going to use this. Okay. Let's do e to the second power. Now, after each one, I'm going to pause for a few seconds so you can pause the video and calculate what that equals and tell me the answer. Alright? So here am I pausing. 1, 2, 3, 4, 5. Okay. So I want you to calculate this in the calculator and tell me what the answer is. I'm going to do the same. And I'm going to do it on camera, hoping that this would help a little bit. Okay, there we go. Tell me if there's a glare in the video, and I'll try to redo it in another video, but I think I got it. Okay, so since you guys have this calculator, these are the sections where you're going to need to use the calculator I suggested. And if you're trying to find it on the one we have, it's right here. So the button that has x to the x times x to the, for 10 to the x power. So multiply by 10 to the x power. Above it, do you see this? Look, there's a red E. See that? So the fact that it's red is telling you that you need to use the button alpha, which is right here. Okay? And as you can see, it's also written in the same color. So all you have to do is press the button alpha, and then press this, and you have an E on your calculator. Saw that? So you press alpha, and then you press the multiply by 10 to the x power. Okay? So now that I have E, the question said E to the second power, so you're going to use the square button right here, and it becomes E squared. And the answer is 7.389, and so on and so on. I hope you got it right. If not, play with your calculator a bit to figure out what you did wrong. But you need to practice using it so that you get ready for logarithms, which you're going to use a calculator for quite a bit. Okay, let's do one more. How about e to the -3 power? So in this one, I'm giving you a -3 power. Now you don't have to erase what you did, just delete the power itself. And then I'm going to type negative, so this is the negative button. Let me zoom go up a little so you can see the entire thing. We have a subtraction here, don't use that. This is the negative sign button right here. That's the one you need. So you press that one, and you press 3 to get a -3 power. Okay? Now let me delete it again so you can see how I did the power. We're back at E. This is just E. There's this button right here. See that? That's a power button. The one right next to it is a power of 2, It's there to make things easier because that's the one people use the most. But if you need another power, like the third, which actually is right there in shift, if you press shift and you press this button again, you get the cubed. But you don't have to do that. You can just use this button. If you click this, you get the square over there. Do you see that? The square right here. This is where you type the power you want. So E could become to the power of 9. It'd be 96. It could be whatever you want. Yeah? And as you delete, notice that the little dash there that's blinking, that shows you that you're typing in the power. And if I erase everything I entered, I see the square again. If I erase one more time, the square goes away. So make sure whatever you're typing is in the square, so it will be a power. Yeah. So anyway, so the power button, you get the square. I press the negative, and then the 3. So that's e to the negative 3 power. And you click answer. So it equals, press the equal button. Oh, I think I need to focus this. 1 second. There you go. Right. So you press the equal button, and your answer is 0.049787 blah blah blah. Right? So I'm gonna type that. I'm gonna write that. So 0.04987. Actually, without 7, let's just round it. How about e to the root of 7 power? How about this one? I'm gonna give you a few minutes to do it, but I'm pausing for a few seconds because you can pause the video. Alright, so on the calculator, I'm just gonna press this arrow right here so I can type and play with it. Now, I have my square. I didn't get out of the square. Do you see this button right here? This can give you square root of any number you want. So I'm going to click that to get the root, and then I'm going to press 7. So now it's e to the power of root 7. And the answer is 14.094. So it's 14.094. Yeah. And last one, e to the, actually let's make that e to the pi. So it's e to the pi power. So pi is a number, and it's in the calculator too. Let me try and find it. There, so e to the power, and pi is actually on the very same button e is on. When you want to get e, you press the button alpha. If you want to get pi, you press shift. Notice that shift and alpha are actually, there. Shift and alpha are written in 2 different colors. One is yellow and the other is red, right? And over here, pi and e are in 2 different colors. So basically, any button you see, if it has something on top of it, if that thing is yellow or golden, then you're going to use shift. If it's red, you're going to use alpha. Make sense? So, to get pi, shift, and then this one right here, and you get e to the pi. Answer. The answer is 23.14069. Let's make it 7. I'm rounding to the 4th place. Alright, so play with your calculator, practice entering powers to different bases. It doesn't have to be E, it could be anything you want, but I recommend practicing E as well because we're going to use it a lot. And as you're practicing, make sure to mix it up. So practice a few negatives, a few roots, a few unusual numbers like pi, just to get a hang of it and get familiar with your calculator. And yeah, that's it. So this is exponential functions. I'm going to pause this video now because the next part of the lecture is going to be about logarithms.